Hello, my name is Azam, and for this presentation, I'll be covering the introduction, the X-ray part. So first of all, radiology department in the Heart Center aid in heart disease diagnosis by method of medical imaging. In our group project, there are several modalities that we suggest to ensure wide selection for the patient and for the clinician to perform the job perfectly. So moving on to the first modalities, which is the X-ray. It is simple and effective. So by X-ray, we will, in terms of X-ray, we focus on chest X-ray, which is the X-ray used for cardiovascular disease diagnosis. And it shows cardiovascular structures. It confirms symptoms of the heart disease, for example, fluid build-up or vessel blockage. And finally, the most, I would say, good thing, the great thing about X-ray is it is quick procedure and it is very cheap for the patient. Next, moving on to the working principle of the X-ray. We have here X-ray generation, which is the production of accelerated electron and it interact with metal to produce X-ray. It can be from characteristic radiation or brainstem radiation. Next, we have the imaging. The produced X-ray then pass through the body and it will attenuate differently depending on the part it hits, and this will produce different contrast between it is more visible for between heart tissues, between heart structure, and body tissue. And next we have image formation, which is the X-ray passing through the body. Some is attenuated and some is passed through the body, and it is detected by the detection plate behind the surface. And finally, after it hitting the detector, it will produce image. And if we adopt the technology of digital radiography or DR, we can post-process the image to help in the diagnostic process. And this is some of the suggested trend from me for DNA, for X-ray, first we have Shimadzu, and then we have from Siemens and Canon. All three of them is great and is elaborated in the report, all the details. And finally, you have the pro and cons. The pros are the good one, and cons, of course, the advantage. First of all, X-ray is simple, quick, and cheap, and this also helps to encourage patients to come for treatment. And next, if we go for digital radiography, we can adjust the dose automatically based on patient size and using the machine algorithm. And finally, for the procedure, it is very easy. The patient doesn't have to prepare themselves too much. Just maybe change the clothes. And for the practitioner themselves, they just need to control everything from the control panel. That's it. Some of the pros. And for the cons, so it's ionizing radiation, so it can induce cancer, although the risk is minimum when we follow the regulation. And next, there is for X-ray, it offers limited information because it can only shows the surface structure, not the internal details of the tissue. And finally, the cons for the X-ray is it can only be taken in limited amount of time. Limited amount of takes because too much take will increase dosage to patient and thus greatly induce the probability for cancer. I think that's it for me. Thank you.
Hi, I'm Hakim and I am the one that responsible to present about CT scan for our radiology department. If I were to summarize CT scan in one sentence, I would say that CT scan is not just a conventional X-ray. But what is CT scan? CT scan is a medical device that uses X-ray technology to get the detailed image of the body. CT scan has a donut-like shape where it contains a rotor that will spin during the procedures. There are a few parts of the CT scan, which are gantry, X-ray emitters and detectors, and the control room. The work mechanism of the CT scan starts by the X-ray emission, where the gantry will spin and the X-ray will pass through the body and detected by the detector. Detector will generate the current based on the X-ray intensity that pass through the body, and then went to integrator to remove the noise and change the format from the analog to the digital. Lastly, the image reconstruction, where it was done by the software in the control room. There are a lot of companies that keep experimenting and try to improvise the CT scan imaging, such as GE Healthcare, the Siemens Healthineers, and Canon, where each of them has their own series of CT scan. CT scan is not a perfect medical device. It has a pros and cons when using the CT scan. If we were to talk about the advantage of CT scan, we would say that it is fast and simple modalities for internal injuries, which allow us to get a detailed image of bone, soft tissue, and blood vessel. And unlike MRI, is not limited by metal implants such as pacemaker, which is make it more versatile. If we were to talk about the cons of the CT scan, there are a risk of cancer, even though the small, and the risk of allergic due to contrast material. And CT scan are very pulse dependent, where the patient need to stay calm during the process. There is a law in designing and conducting the procedures of the CT scan. The law that related to the CT scan is the Law of Malaysia Atomic Energy Licensing Act 1984. In the law, it said that the user must possess annual practicing certificate in order to conduct the procedures in the CT scan room. The CT scan need to have a scheduled maintenance for its generator, dosimetry, image quality, and etc. As for the room of the CT scan, it must follow the minimal requirement of the act, such as the thickness of the wall and the coating of the lead. That's all from my part. Thank you.
Hello, my name is Hazim and I will discuss ultrasound machine. Ultrasound machine is an imaging modality that uses high frequency sound wave, also known as ultrasound wave, to produce image of internal structure of human body such as organ, tissue, and so on. There are several types of ultrasound machines such as Doppler ultrasound machine, cardiac ultrasound machine, and endoscopic ultrasound machine. It can be used to scan several parts of human body to obtain real-time images. Ultrasound machine use piezoelectric crystal to transmit and receive ultrasound wave. It is a cheaper and faster in terms of procedure cost and duration respectively. There are two main components in the machine, which are transducer and processor unit. Next, imaging process in ultrasound can be simplified into four stages, starting from emitting phase, where electric current flow through piezoelectric crystal to produce high-frequency sound wave called ultrasound wave. The generated wave will be directed towards patient organ such as heart. Hence, the ultrasound wave were reflected by the surface of target organ. After that, the reflected wave will travel back towards piezoelectric crystal inside the transducer. It causes the crystal vibrate and produce electric current. The electric current from vibrated piezoelectric crystal will be converted into electrical signal. Finally, the signal will be translated and interpreted by processor of ultrasound machine to form an observable image of targeted organ. As for model and brand, ultrasound machine is one of a common medical imaging modalities. There are several types, model, and brand of ultrasound machine. Many huge medical companies such as Philips, Mindray, and Samsung Medicine have developed and supplied ultrasound machine. For instance, Philips EPIQ7 is a famous and convenient model of ultrasound as it is mobile and easy to operate. Other than that, Mindray M7 and Samsung Ogeo Ash M70A model are complex and portable. Next, the advantages and disadvantages of ultrasound machine. For advantage of an ultrasound machine, let's start with safe procedure. It is safe because patients are not exposed to ionizing radiation, and this makes it safer procedure compared to X-ray and CT scans. There are no known harmful effects if it is properly taken as prescribed. Next, it is widely accessible as compared to other methods of capturing imagery because it is less expensive and faster imaging procedure. Ultrasound machine is also capable of producing real-time images of soft tissue or organ, which will enhance the diagnostic and treatment process. On the other hand, there are a few limitations such as low image resolution. Other than that, the ultrasound wave have lower penetration towards bone or parts of the body that hold air and gas. Lastly, the results are difficult to interpret because artifacts are common in ultrasound procedure images. Hence, an experienced sonographer is required to analyze the image properly. Lastly, for safety measure of using ultrasound machine, there are three main safety aspects, which are ultrasound machine, operates or storeroom, and sonographer. For ultrasound machine safety aspects, the device need to be maintained properly to prevent breakdown. Next, the machine need to have MDA approval. It is also should follow a related electrical and mechanical standard for medical device such as IEC 60601. Next, the room which being used to store or operate the machine does not need any specific safety requirement as ultrasound machine does not operated by using radiation or ionizing resources. Finally, the users of ultrasound machine, which is the sonographer, need to has qualification and certified to operate the machine. That's all for ultrasound machine.
Hi, my name is Syamil and I will present MRI. What is MRI? MRI stands for magnetic resonance imaging. MRI is a medical imaging method that creates detailed image of internal organs and tissue. The MRI revolutionized the medical industry as they are saying that goes by. If the history were overwritten and the MRI were first developed, nobody would bother to pursue CT scan. The reason being that MRI produces much better image quality as compared to CT scan, and without the dangers that come with the radiation from CT scan. There are many different types of MRI to accommodate different type of patient. There are general MRI, open bore, wide bore, for comfort and for larger patient, and open type MRI that also have the same function. For a cardiac center, MRI is a must-have imaging modalities as it produces the best image for diagnosis to the smallest detail other imaging modalities could never produce. Next, the working principle of the MRI. The magnetic field will go through the patient's body, causing the protons in the body to align themselves to the field. Radio frequency currents will then pulsate through the patient to stimulate the protons. The radio frequency will then spin out of equilibrium, straining against the pull of the magnetic field. The radio frequency field will then turn off to induce the energy released by the proton in the patient's body that realigns themselves to the magnetic field. MRI sensor will then pick up the energy, which then produce the image. Next, I will compare the brand of the MRI. The first brand that I choose is the Magnetom Solar from Siemens Healthineers. This MRI is a wide bore MRI, making it comfortable compared to normal MRI. The magnetic field strength of this system is normal, which is 1.5 Tesla. Onto the next MRI system is the Signa HD3 by GE Healthcare. The system boasts 3 Tesla magnetic field strength, which make the procedure can be conducted faster. However, this system have smaller space than Magnetom, making it less comfortable. Finally, is the Fujifilm Oasis. That uh, the the configuration of this is that it is an open bore MRI system. The drawback, which is it is the most comfortable. The drawback of this MRI is that it is low. It has low field strength of only 1.2 T, making this the slowest system out of all three. This open MRI is actually made to accommodate larger patients. Continue to the pro and cons. The advantages of MRI is that MRI is a radiation-free imaging modalities. MRI provides the best image quality out of all other modalities. Next, the contrast material usage will not likely to cause allergy reaction to the patient as compared to iodine-based that are used in the X-ray and CT scan. The disadvantages of MRI is that MRI is very expensive, so it is not a feasible option for many. Next is that there are lots of safety precautions when using MRI. Finally, MRI get extremely hot when operating, where patient can get burned. Radio frequency is also potentially can cause burn to the patient. Finally, the safety and precautions of the MRI is that the first point is that uh, MRI are regulated by FDA, IEC, and Malaysia standards. Being a Class 2 medical device, it can potentially cause harm to human, thus making it needed to be certified before even being marketed. Next is the contrast material. The contrast material needed to be approved by FDA before it can be given to the patient. Finally, the room of the MRI. There are so many strict requirements needed for the room to be certified, for the room to be according to the standards. So for this one, I will continue the explanation in the design section. Thank you very much.
Hi and hello to Dr. Liu. My name is Amien binti Ahlin and I'll be presenting on fluoroscopy modality. About fluoroscopy. Fluoroscopy is a medical imaging technology that allows clinicians to take a still photograph of certain organs while simultaneously watching a movie or real-time X-ray viewing of the movement of various body components on a fluorescent screen. These technologies can provide imaging guidance for interventional procedures by providing information that will be impossible to assess through other methods. This modality is extensively used in many types of examination and procedures guidance such as barium X-rays, cardiac characterization, lumbar puncture, and many more. For cardiac fluoroscopy, it is commonly performed when a blockage is suspected, and the operation can aid in the insertion and advancement of a catheter used to diagnose and treat the issues. Next, for working principle, fluoroscopic equipment consists of a X-ray source, beam filtration, collimation, anti-scattergrade, X-ray image intensifier, and image receptor or flat panel detector. The X-ray source is typically the same tubes and design as other general radiographic application. And during beam filtration, the insertion of beam filtration in the beam path may be user selectable, which can provide the operator with the flexibility to switch between low dose and higher dose modes. The collimation acts as shutters that limit the geometric extent of the X-ray field that are present in all X-ray equipment. In fluoroscopy, the collimation may be circular or rectangular in shape, matching the shape of the image receptor. For anti-scatter grids, these are the standard component in fluoroscopic system, since a large percentage of fluoroscopic examination are performed in high scatter conditions, such as in abdominal region. The typical grid ratio is ranging from 6:1 to 10:1. And the grids may be circular for X-ray image intensifier system or rectangular for flat panel display system, and they are often removable by the operator. And next, the image intensifier is an electronic device that converts the X-ray beam intensity pattern into a visible image, which is suitable to capture by a video camera and displayed on a video display monitor. And the key component of an X-ray image intensifier are an input phosphor layer, a photocathode, electron optics, and an output phosphor. And lastly, the flat panel detectors are more physically compact than X-ray image intensifier system, which allow more flexibility in movement and patient positioning. However, the most important benefit of flat panel detector is that it does not suffer from many inherent limitation of X-ray image intensifier. Next, there are three types of models that I have identified, which are Philips, Newsoft, and Ellanges. These are three models that are designed specifically for cardiac fluoroscopy, and due to limitation of time, I will not be explaining the three models. And the most advanced model is from Newsoft, which can produce full 16-bit and 2K digital imaging change. For advantages, it acts as a procedure guidance for clinicians to decide which therapy will be needed for further treatment. It also can allow clinicians to see movement and function that cannot be visualized in other fixed imaging studies. For example, it involves emplacement of devices within the body, such as stents to open the narrow or block blood vessel. For disadvantages, like other general radiography, it can expose the user to significant levels of radiation, and it also causes radiation-induced burns to skin due to prolonged radiation, primarily for stenosis treatment. And lastly, this technology requires high cost as compared to X-ray modality. For safety and precaution, there is act and regulation like other described modalities, which is Law of Malaysia, Atomic Energy Licensing Act 1984. And for personnel, it requires specialized protection from radiation, for example, lead apron, uniform, and sheets. The fluoroscopy machine also must always go for scheduled maintenance and equipped with dosimetry for radiation monitoring. And lastly, the thickness of the room wall and coating must be assessed by the experts. That's all from me. Thank you.
Hi, this is Syamil again, and I will be presenting the design requirements for the imaging modalities room. The design requirement of the imaging modalities room differs from one another. For X-ray and CT scan room, both have the same requirements for the room design and material usage for the barrier. Both rooms are needed to be X-ray insulated. This is covered under the radiation committee. This is overseen by the radiation committee of the Malaysia. For the purpose of protection from surrounding, especially protection for practitioner that will always be there most of the time. By using a suitable thickness of lead, all part of room, including the wall, floor, and ceiling, are covered by using suitable material in order to prevent the leakage of the X-ray radiation. Next is the MRI room. For MRI room, the requirements are focused on the radio frequency shielding and the magnetic field shielding. The radio frequency shielding purpose are for the MRI machine to obtain a good quality image, There are many other devices outside of the MRI that have radio frequency that can possibly cause noise. So by having the shielding, it prevents the noise from happening, thus making the image thus making the good quality image. The floor, wall and the ceiling needs to use suitable material. The room in the end must be fully insulated with only controlled air, liquid, and solid that can be passed through. So every single matter needs to be controlled in and outside of the room in order this is for the safety purpose. Next is the ultrasound. For ultrasound, it does not require any special equipment, nor does it takes a room. Some ultrasound machine ward are just like any other ward. That is all from for the design equipment.
Best combination of imaging modalities are all four devices, which are the cardiac ultrasound, X-ray machine, CT scan, and MRI. The justification for having all modalities in our heart center is related to their own strengths and weaknesses. No modality is the best for all types of patient cases. The combination of the modalities can cover each other's weakness while highlighting each other's strengths in the process. Next, having many types of the modalities also provides option for the patient. Patients should have freedom in choosing method of diagnosis within the recommendation by physician. Other than that, having multiple modalities also increase the center robustness in accepting different type of patient with different heart diseases symptom. Lastly, multiple modalities also reduce the monetary pressure for the patient. For example, if the radiology department only have MRI unit to diagnose patient, they might feel pressure to go for checkup since they are expected to pay large sum of money per visit.
From this report, we are able to conclude that imaging modalities has helped a lot in our current health technology and diagnosis, and we are expecting the constant progress in imaging technology will improve image quality and details and open more opportunity for research to increase our knowledge regarding human anatomy. That's all from us. Thank you.